So here we are with the lecture 3 of amines. In this we will be studying the reactions of amines. First reaction is alkylation of amines, Hoffmann's exhaustive alkylation. So when a primary amine is reacted with excess of primary alkyl halide, it gives a mixture of secondary amine, tertiary amine along with tetraalkyl ammonium halide. If excess of alkyl halide is used, tetraalkyl ammonium halide is formed as a major product, and this reaction is called exhaustive alkylation. So tetraalkyl ammonium halide is also known as quaternary ammonium salt, which are crystalline solids. They are the derivatives of ammonium salts in which all the 4 hydrogens are replaced by 4 alkyl groups from ammonium ion. Primary, secondary and tertiary amines consumes 3, 2 and 1 mole of alkyl halide respectively to get into quaternary ammonium salt. Okay, now let's see the reaction. Here we see this is methylamine reacted with methyl iodide under the same conditions, that is 100 degrees centigrade sealed tube. We get dimethylamine, that is a secondary amine. Then dimethylamine reacts with methyl iodide to form tertiary amine, and tertiary amine reacts with another molecule of methyl iodide to form quaternary ammonium salt. So when methylamine is heated with excess of methyl iodide, it gives this tetramethyl ammonium iodide at the end. This tetramethyl ammonium iodide is known as quaternary ammonium salt. Okay, so instead of NH4I, the ammonium salt would have been NH4I. Here the 4 H's are replaced by the methyl group. So you get CH3 whole 4N plus I minus. So this is quaternary ammonium salt and tetramethyl ammonium iodide. Okay. Okay. So Hoffmann elimination reaction. In this, when tetraalkyl ammonium halide or tetraalkyl ammonium iodide is heated with silver hydroxide, that means moist silver oxide, it gives you the quaternary ammonium hydroxide, which is a deliquescent crystalline solid, strongly basic like sodium hydroxide and or KOH. This quaternary ammonium hydroxide, on strongly heating, what happens? The ethene is formed and NN diethyl propylamine is formed. Okay, so basically here in this reaction, elimination gives you an alkene, and the reaction is called Hoffmann elimination, and the least substituted alkene is formed. Okay, so here you are having propyl group, here ethyl and ethyl. So 3 ethyl groups are there. So one of the N-C bond breaks and you get ethene, and along with that, and water is given out. Okay, so CH3 CH2, no, so this converts to CH2 double bond CH2. The H comes from here, reacts with OH, water is given out, and you get the alkene, least substituted alkene. Okay, so this is called Hoffmann elimination reaction. So what happens here? Tetraalkyl ammonium halide is heated with silver hydroxide. With silver hydroxide, moist silver hydroxide. Ag2O plus water gives you AgOH. So this one reaction gives you the quaternary ammonium hydroxide, and this one further strongly heating, one of the NC bond breaks and the least substituted alkene, that is ethene, is formed, along with this amine is formed. Okay, so N diethyl propylamine is formed, tertiary amine is formed. Right? Clear? Okay. Acylation of amines. Aliphatic and aromatic primary and secondary amines, they undergo acylation reaction. These amines, replaceable hydrogen atoms that positively polarize hydrogen on the nitrogen atom. These hydrogen atoms are replaced by the acyl groups, such as acetyl group. On reaction of amines with acetyl chloride or acetic anhydride, acetyl derivative of amine is obtained. So this is called amide. Amide is less basic than amine. So acylation is actually a nucleophilic substitution reaction, and the reaction is carried out in the presence of strong base like pyridine, so in which neutralizes the acid produced during the reaction. So this pyridine basically neutralizes the acid produced during the reaction. Now let's see the reaction. Here you see ethylamine when reacted with ethanoyl chloride It is an acyl group, CH3CO group. So in the presence of pyridine, it gives you this intermediate, and this, when HCl is given out, it forms an ethyl ethanamide. So basically the ethanamine gets converted to the ethanamide. Okay, so in this reaction, the pyridine this reaction is done in the presence of pyridine, which reacts with HCl, and the rate of the forward reaction increases. The main product is formed. More product is formed. So this is the primary amine reacting with ethanol chloride, giving you ethanamide. Okay. So now if it is secondary amine, then also the same reaction takes place. So if you have N-methylaniline, it is reacted with acetyl chloride or ethanol chloride. It gives you N-methyl, N-phenyl ethanamide. So basically ethanamide is this group, CH3CON, and N-methyl N-phenyl ethanamide is formed along with HCl. So the primary and secondary amines gives this reaction because of the presence of the hydrogen group. Okay. Then carbylamine reaction. Aliphatic or aromatic primary amine on heating with chloroform and alkali gives you a foul smelling product called alkyl or aryl isocyanide, or also known as carbylamines. Okay, and the side products are KCl and water. So secondary and tertiary amine do not give this test. This test is given only by the primary amine. So primary amine on reaction with chloroform and KOH and heating gives you the foul smelling alkyl isocyanide plus KCl plus water. And secondary and tertiary amine do not give this reaction. What is the name of this reaction? Carbylamine reaction. Right? Then reaction with nitrous acid. Primary, secondary and tertiary amines, they react differently with nitrous acid. The reactions of only primary amines will be considered here. Okay. So aliphatic primary amine on reaction with nitrous acid gives you aliphatic diazonium salt. Aliphatic diazonium salt is very unstable, which decomposes, and it gives you alcohol plus nitrogen. Gas is liberated and HCl. Okay, so the primary amine, they react with nitrous acid. How is the nitrous acid produced? It's produced by the reaction of sodium nitrite and hydrochloride. So this HNO2 is not available in the lab. You have to prepare it in C2, that is by the reaction of NaNO2 and HCl. In the temperature conditions should be 0 to 5 degrees centigrade. So alkyl diazonium salt is formed. Alkyl diazonium chloride is formed. This is highly unstable and it splits into alcohol, nitrogen gas is liberated, and HCl is formed. So the corresponding alcohol is formed having the same number of carbon atoms. Okay, so this is reaction with primary amine. Now aromatic primary amine, they also react with nitrous acid 0 to 5 degrees centigrade, giving you benzene diazonium chloride. Okay, so this is aniline when reacted with HNO2. Where does the HNO2 come from? NaNO2 and HCl. At 0 to 5 degrees centigrade, it gives you benzene diazonium chloride. So this aryl diazonium chloride are resonance stabilized and useful as a versatile intermediate to obtain variety of products. So here you see this is resonance stabilized. It is highly stabilized. It's having resonance structure. So reactions of involving displacement of diazo group. Now the diazonium salt is a very good leaving group due to the positive charge on it, nitrogen atom bonded to the aromatic ring. As a result, the arene diazonium salt undergo nucleophilic substitution reaction with a variety of nucleophiles. Let's see the reaction. So here you see Sandmeyer's reaction. The diazonium salt reacts with CuCl and HCl, giving you this chlorobenzene plus nitrogen. Then diazonium halide reacts with CuBr, HBr, gives you the bromobenzene, bromo derivative. Then the diazonium salt, when reacted with CuCN, KCN, it gives you the aryl cyanide. Okay, so this N2 is a very good leaving group, and it leaves and it forms the uh, nitrogen gas is liberated in all the reactions here. Okay, then Gattermann reaction, when this diazonium halide is treated with copper powder and HCl, you get chloro aromatic derivative and plus nitrogen gases liberated. Then if diazonium chloride is treated with Cu powder and HBr, you get bromo derivative of aromatic compound plus N2 is formed. Then iodoarenes are prepared when diazonium chloride is formed with Ki, you get iodo compounds plus nitrogen. Then this, when reacted with H3PO2 and water, it gives you benzene plus nitrogen plus H3PO3 PO3 is formed. Then diazonium chloride, when reacted with ethyl iodide, ethyl alcohol, that also forms the benzene. Then when diazonium chloride is reacted with water at 283 Kelvin, it forms phenol. So number of compounds are formed from the diazonium chloride. Then Sandemeier's reaction, a very well-known reaction. In this reaction, nucleophilic attack by chloride, bromide, cyanide respectively upon diazonium solutions leads to the evolution of nitrogen gas, chloride ion, and the chlorobenzene is formed. Okay, so bond treated with Cu2Cl2 and HCl. Okay, so and the formation of aryl chloride, aryl bromide, aryl cyanide happens in these three reactions. So diazonium chloride plus Cu2Cl2 HCl, it gives you the chloro compound plus nitrogen plus chloride ion is formed. Or diazonium chloride when treated with Cu2Br2 HBr, it gives you bromo compound plus nitrogen plus chloride. Then here when diazonium chloride is reacted with CuCN HCN, it forms cyano compound plus nitrogen plus chloride. Okay. Then Gattermann reaction, diazonium chloride, when treated with CuSCl, it gives you chlorobenzene plus nitrogen. When treated with CuHBr, it gives you bromobenzene plus nitrogen plus chloride. Okay. Then when diazonium chloride is reacted with Ki warm, you get iodobenzene plus nitrogen plus KCl. So see how the diazonium chloride reacts with different compounds. When diazonium chloride is treated with phosphoric acid, in the presence of water, this is a mild reducing agent. It forms arene plus phosphorus acid plus HCl plus nitrogen is given out. In all the reactions, nitrogen is given out. Then if diazonium chloride is reacted with ethyl alcohol, there also it forms arene plus acetaldehyde plus nitrogen plus HCl is formed. Okay. Then when diazonium chloride is reacted with water, is warmed with dilute sulfuric acid, then you get phenol plus nitrogen plus HCl. Okay, so this is how we see the number of reaction this diazonium salt undergoes. Okay, when treated with HbF4 fluoroboric acid, it forms fluorobenzene. When reacted with water, it forms phenol. When warmed with Ki, it forms iodobenzene. When reacted with CuCN HCN, it gives a cyanobenzene. Then if reacted with H3PO2, you get benzene. Then when this benzene diazonium chloride treated with CuBr HBr, it forms bromobenzene. When reacted with CuCl HCl, it forms chlorobenzene. So number of reactions this diazonium salt undergoes.